Hi guys, I think this is a review section for you. We're going to multiply polynomials. This is usually an Algebra 1 topic. It is showing up here in Algebra 2 in Chapter 11 because we'll be doing some more things with polynomials, but this is not difficult at all, and I'm really going to think you think this is cake when we're all done here. Okay. Here are words you need to know. We've talked about some of these, I think, even in the previous lesson. A monomial is a polynomial. So that was a question that came up. A monomial is a polynomial, even though by definition their roots are different. Technically, a monomial is a polynomial. There's just one term. So 2x, negative x squared. Those are some examples. Binomial is a polynomial with two terms. They have two pieces. Basically, there's going to be either one addition or subtraction sign. A trinomial is a polynomial with three terms, and so on. After that, I don't think they have any special names. I just call it like a polynomial with four terms or something. The degree of the polynomial in several variables. Sometimes x and y show up together, being smushed together in the terms of a polynomial. So look, I have x squared y to the third. That degree gives me 5. You do add them. Okay? You add the total exponents. So this would have been 3 if that was the biggest one, but it's not. That's 5. This would have also been 3. But it's a degree 5 because you take the largest sum of the exponents of any term. So 2 plus 3 is 5. Okay? That will be the hardest part for you in these words to know. Okay, you've heard of the word FOIL before. I try to avoid talking about it anymore. When I was a student, I actually thought it was the name of a guy, Mr. Foil. It is an acronym. It stands for first, outer, inner, last. But what does it mean to you if we couldn't use those words? Okay? What foiling does is it's a shortcut way to multiply two binomials. It only works with two binomials. So that's why a lot of math teachers hate the word FOIL, because kids think it works for everything. It only works when multiplying binomials. So I have x plus 3, maybe y minus 4. Okay? It is technically, when you do the first, you're taking the x times the y. The outer, you're taking the x to the negative 4. When you draw arrows like that, it should remind you of distributing. Basically what FOIL is double distributing. First you distribute the x, then we distribute the 3. The inner is here, then the last. I prefer to call double distributing, triple distributing, whatever we need to do, because that works for everything. Foiling only works for binomials, and we're going to do lots of things where you don't multiply binomials. So FOIL is kind of a thing that they used to use. It's when they introduced this double distributing, but I like to call it double, triple, multi-distributing, whatever. Okay, when we multiply polynomials, you must double, triple, even more times distribute. Multiply each term of the first polynomial by each term of the second, and then you're going to combine your like terms. Sometimes they get messy. You don't always have to expand all the way to get a term you need, because sometimes they're just going to ask you for a specific term, but you can. You still have that option. To be honest, most times I do go ahead and distribute all the way out because I'm pretty good at that, and I'm less likely to make a mistake if I'm very systematic. When I start trying to shortcut way through things, then I usually do mess up. So here's an example. We're going to expand this guy. 5x squared minus 4x plus 3 times x minus 7. Okay? I usually do like to have the x minus 7 first. That is completely up to you. I like to have the smaller one in front, but it is up to you. So I'm first going to distribute the x. 5x to the third minus 4x squared plus 3x. I distributed the x. Now I'm going to distribute the negative 7. Be careful. You are using that sign when you distribute. Negative 35x squared plus 28x minus 21. This is fun. Okay, combine like terms. Make it nice and neat, hopefully in standard form. So start with our biggest exponent, which appears to be 3 here. 5x to the third. Then we're going to go to the squared terms. I got negative 4x squared, negative 35x squared. Be careful with your signs. I get negative 39x squared plus 3x plus 28x. So it looks like a plus 31x minus 21. That is fun. Okay, moving on to an application problem. We are going to take the volume of this box. Do you know how to find volume of a box or a rectangular prison? I hope you do. Length times width times height. So we're going to multiply its dimensions. How long is this side? That's D. How long is this side? Do not tell me A, B, C. Why would I multiply those lengths? If this was 2, that was 3, and this was 4, how long is the length? 7, 8, 9. It is not 6, 24. You don't multiply them. You add them. So I'm going to have D times A plus B plus C times A plus E. We add to find those lengths. I wrote them in this order. I probably, if I was going to rewrite it, would have put the A plus E next. Again, it's easier for me to start with the smallest, like monomial, than binomial, than trinomial. It just helps me stay organized. It is not necessary. So this time I won't do it in that order, just so you can see. I'm going to distribute the D first. I get dA plus dB plus dC times A plus E. The dA goes first. dA squared plus DAE. I don't know why I put a parenthesis there. It's kind of stupid. Pretend I didn't. Ooh, that's a really big eraser. I can simmer down there. Okay. Now I already did that one. Let's distribute this dB. dBA. I should have put these in alphabetical order, but I didn't. dBA plus dBE I have no clue where I left off. So it looks like dBA and then dBE. So I did do both of those. Okay. And now we're going to take this DC. It gets a little sloppy. Do you see how it gets more sloppy when you have the trinomial first and then the binomial? I just don't like all the arrows. It stresses me out, causes some anxiety. So I have DCA and then DCE. Okay. I don't believe there are any like terms here. We could take a look and see. No, definitely not for this one. DAE, nope. DBA, nope. Okay, no like terms. Those is as good as it gets. You could alphabetize the letters if you want, but it's not that big of a deal. Now, they want to find the volume V of the large box by adding all the volumes of the small box. What they're asking us to do here, and I think this is a really interesting question, is there are 6 boxes if you look carefully. Can you see all the 6 boxes? See, no, that's just too small. Okay. Length times width times height still. So this will be A times D. That's A squared times D. If I take B times A times D, that's BAD. C times A times D, that's CAD. E times A times D, EAD. EBD. And ECD. They want us to show that they're equal. Let's look. EAD, EAD. They're there. A squared D, both there. EBD, both there. ECD, they are equal. Okay? So the way you would show they're equal technically is you would write all these down and add them together and then make sure that you match them out, or you could subtract them out and say they're 0. Something along those lines. Okay. This is what I hate. I'm really bad at these. It says without expanding, find the leading term, the last term, and the coefficient. Okay, first of all, the leading term is easy. To find the leading term, it'll be the highest exponent. So you're basically going to pick and choose the highest exponent out of each piece, because all 3 will eventually be multiplied, and we're going to multiply them all together. So 5x squared, not plus, come on, stupid math teacher, times 4x squared times 11x. Okay, so we get 20x to the 4th times 11x 10. And we get 220 x to the 5th. That will be our leading term, because you're going to take the largest exponent out of every quantity that we're multiplying together. The last term, we are going to take the lowest exponent in each quantity. So we'll take the 2 times the 8 times the, be careful, -3. And we get 16 times -3, which is -48. Okay, and it says the coefficient of the term with the x to the third. Here's where I'm bad at this. And this one is not as hard as some of them. I will be honest with you. I sometimes like to expand 2 of them. I can see it after I do 2. It's harder for me to do it with just 3. You have to think of every possible way I can multiply these together, picking one of each that will give me an exponent of 3. So if I take 5x squared, I have x squared, and if I multiply it by this 4x squared, I get x to the 4th. So I'm never going to multiply by that. Multiply by this 8. 5x squared times 8, that's 40x squared. And if I multiply by this 11x, I get 440x to the 3rd. Okay? That's one way. What if I use the 2? I'll go with green now. If I pick the 2, and I take the 2 times the 4x squared times, I need one more x, the 11x. That gives me 8x squared times 11x, which is 88x squared. So if I take those two numbers and add them together, not x squared, excuse me, x to the 3rd, I add them together and I get the 528x to the 3rd. So you have to find one from each to multiply together to get an x to the 3rd. Okay, if you don't like that, what is your option? Well, your option is just to multiply them out like you already know how. Don't shortcut it. Or you can do it until you can see a shortcut easier, and that's what I like to do. I'm going to pick 2 to multiply here. I'm going to go ahead and multiply the first 2 since they're right there. 20x to the 4th plus 40x squared plus 8x squared plus 16. 20x to the 4th plus 48x squared plus 16. If I take that times 11x minus 3, which one's going to give me the x to the 3rd? If I take this 48 times the 11, that will give me an x to the 3rd. And that's where I get the 528 x to the 3rd again. See, I can see it easier from here. It's harder for me to see when I have to take one from each. It's up to you what you want to do on that. This is the hardest part, finding like an abstract, like middle of the road exponent in the middle of the polynomial. That's harder for me. Okay, your homework's going to be 11-2B. I'm going to have a worksheet for you, and then these extra problems, not too many, 18 through 20, 22, and 24. Okie dokie.